shaving cream on it. They don't want it mounds and mounds.
Yeah.
You just want a flat platform. So soap has two ends to the molecule. One that combines with water, which is polar, and water is polar, and one that combines with dirt, which is usually grease or grime, nonpolar. So if the soap molecule looks like this, one end here and one end here, this end combines with the grime and pulls it away with the water. This arm is just like water, so it stays dissolved in water. So the soap molecule itself only dissolves on one end, if you want to think of it that way, and it latches on to dirt or grime with the other side. This is called polar, so it has a charge to it, and water has a charge. So positive and negative attract. This one is non-polar, and grime is usually oil or fat or something like that, and that's also non-polar. So we say like dissolves like. Polar dissolves polar, non-polar dissolves non-polar. Now what makes them polar or polar has to do with whether there's a charge on the molecule. If there's a charge, the molecule is polar. It has two poles, positive and negative. If there's no charge on the molecule, it's non-polar, meaning there's no charge. So soap is kind of, one side has charge, one doesn't. When you get to anything that's dissolved in water, like food coloring, this is polar. So it will stay attached to the soap. And I could actually dissolve it in the soap. It's not perfect because there's only one side of the soap molecule, this side, that's dissolving the food coloring. So you can pick any colors you want and put a couple of drops on this new smooth base. Don't use more than 2 drops of any one color because I'll show you what happens. And then what you're going to do is to swirl them together and make a design. Now that is staying attached to the soap because it's dissolving in the soap. But paper is definitely polar. So it's polar on both ends. So when you have the food coloring stuck between a polar and a non-polar and a strictly polar, and you press it down, the food coloring will actually be attracted to both, but stronger to the paper. So when I lift up the paper, the color will come with the paper, and then you just scrape off the extra. Now we use these, we used to always do a Christmas lab where the kids made Christmas ornaments that had a chemistry theme. And if they could explain the chemistry behind it, they could take the Christmas ornament home. So we used this marbling technique to make gift tags or Christmas cards. So now the food coloring is attached to the paper because there's a stronger attraction than there is to the soap. And that's because the soap is only partially polar, whereas the paper is all polar, and so is food coloring, all polar, because it's dissolved in water. So why don't you try it? I have some paper here.